All right, students. So this question is again from the topic of kinetic theory of gases. Quick revision for JEE mains for you. Now read the question. Okay, so you have a monoatomic gas, and then it has a certain pressure and a temperature. There is another container, okay, which contains the gas B, and the volume is same, the pressure is double, and the temperature is T by 2. All right, so you have to calculate the ratio of the average kinetic energy per molecule of gas A to B. Okay, so you're given two gases. A lot of students have confusion in these questions, right? And the confusion is deliberate. Now, I'll tell you why the confusion is deliberate, especially when we talk about the average kinetic energy per molecule, right? The confusion is there because of because they give so many parameters: pressure, volume, temperature. Here we have to slow down and really listen to the question very carefully. Why? The average kinetic energy per molecule is written as 3 by 2 kT, right? Which means the average kinetic energy of a molecule is only dependent on only one thing: temperature. Remember this: the average kinetic energy of a molecule does not depend on pressure, volume. See this simple formula. It depends only on temperature. So your focus has to be always the temperature. Pressure, volume, and stuff like that does not matter. So if you were to do a fair comparison of the kinetic energy in this question, you would say the kinetic energy of the first is 3 by 2 kT, okay? And the kinetic energy of A and the kinetic energy of B is going to be what? The kinetic energy will depend on the temperature of B. It's in a different container altogether. I will tell you why I'm saying different container. So this also is going to be 3 by 2 K T by 2. Please ignore pressure and volume in such questions. Don't get carried away that we have to use it, because such a very basic concept has to be, used here. 3 by 2 kT. So obviously you have to find the ratio of the kinetic energy of A to B per molecule basis. So KEA divided by KEB is equal to T divided by T by 2 is equal to 2 is to 1. That's your answer. Now let me do a bonus question for you. How will you solve such a question? Okay, if you have the mixture of the gas, what trick will you use, right? So you pick up the two gases which are given to you, A and B. I already have this question solved in my playlist. Go and watch. But I'm going to tell you some conceptual stuff so that it's easier for you to solve. When you have two gases, okay, so these two containers are brought and in a common container, right? Say of some volume. Finally, what happens? And you're supposed to find the average kinetic energy in that situation, that these two containers at different temperatures are brought and put in a single container of some volume. You have to arrive at the logic of what? You have to arrive at the logic. Again, the average kinetic energy is a function of temperature, nothing else, right? So how do you handle this? What you have to do is the container number 1 and the container number 2, they get into maybe some volume, right? You have to focus on thermal equilibrium. Once the thermal equilibrium, which means the mixture attains the common temperature, what are you supposed to do? You're supposed to apply the 3 by 2 kT rule as per the thermal equilibrium temperature, right? Now, how do you do the thermal equilibrium? Go to my playlist, you will find mixture questions, very important questions, but I'll give you one more hint. Apart from thermal equilibrium concept, one more additional concept for you, which will remove your confusion. The idea is to remove your confusion, bring a lot of clarity. Now let's talk about what exactly are we referring to. So a lot of students also are given additional information in the question, right? Monoatomic gas and the other gas is monoatomic. So that doesn't create confusion in your mind. What if In the same question, the other gas is diatomic, which means the gas number B is diatomic, the gas number A is polyatomic. And you're still supposed to find, sorry, monoatomic. Gas number A is monoatomic, gas number B is diatomic or triatomic, which means different gamma, the adiabatic index, right? When I say gamma, so let's say gamma for this is A and the gamma for this is B. What is going to change? Nothing is going to change. Reason is very simple. The average kinetic energy per molecule has no expression place in it for gamma. Where is the adiabatic index written here? No adiabatic index is given. Why will you use gamma? Don't get confused. If it is a monoatomic gas, the other is a diatomic gas. One is at a temperature T, the other is at temperature T by 2. Makes no difference to your life. The gammas, which is the adiabatic index, is mainly for Cp by Cv, which means your whole focus there is degree of freedom. But the average kinetic energy per molecule is still 3 by 2 kT. It has nothing to do with the gas being monoatomic or diatomic. Gamma has everything to do with degrees of freedom, right? Which is, but the average kinetic energy still remains the same for both the gases. That's another confusion students have, and therefore I thought it would be important for me to address this also. So I hope this quick revision of kinetic theory of gas helps you, and this question also helps you, and the bonus question also helps you. This is the only channel in the country which is giving explanation and trying to improve your clarity of the concepts. There is no gimmick, there is no nothing. Pure education is being done, pure explanation is being done for your exam benefit. Do not forget to subscribe to this, as I'm coming with flurry of videos on JEE Mains quick revision. Thank you very much for your time, and wait for my next video.